Hi guys, welcome to my tool shed. My name is Mark. This is my first video, um, inspired by the people who are prolific machining video makers, like of course Mr. Pete, Lyle Peterson, Adam Booth, Keith Fenner, um, Tom Lipton. There's too many to list, but those are some of my favorites. I love those guys. A little bit about me. My background is I've been an electrician all my life. I've been an electrician for about 26 years. I mostly worked in factories. Factory electricians are generally attached to the maintenance department, so that means that regardless of what your job title is, you're the guy that's got to get it done. And I was fortunate enough in my lifetime to have been attached to a tool and die shop, a very large one, where I got formal machine shop training, although that was never my job. I'm grateful for that. That was free tuition, and it's turned into one of my hobbies. Machining has, and so I thought maybe I'd make a few videos. There's hardly any topics that haven't already been covered in far more detail and with greater skill than I could, but I've been restoring a South Bend 9-inch lathe lately. 9-inch junior, as I discovered. I didn't know quite what I bought until I started working on it, and through the process I figured, well, there's some video worthy things that I've come across that folks haven't covered yet, and I thought I'm getting ready to mount this 9-inch junior eventually on the bench here in the tool shed, but I carried the horizontal countershaft out. I did a bunch of stuff to it, and I thought, well, maybe I'll go over the horizontal countershaft in detail. As I discovered, my 9-inch junior came from the Craigslist buyer that I got it from with this horizontal countershaft. I think I've determined that this was not at all the correct horizontal countershaft for the 9-inch junior. From the casting numbers, I think my 9-inch junior is from 1928 by serial number, but I think this horizontal countershaft is from the 40s, near as I can tell. But I've done a bunch of things to it. Of course, part of any restoration project is tearing everything apart, stripping it, repainting it, figure out what's worn, replacing what's worn, remaking what's worn if it doesn't exist, trying to find it on eBay and the secondary market and so forth. Practical Machinist website has been a great resource for the South Bend rebuilder. I've been reasonably active on there, although I've had to eat crow many times. I thought I knew the answer. I would answer someone's question, and it turns out I'm no kind of authority at all. But I know all about this horizontal countershaft now. Well, let's get into it a little bit. It's all together now. I think I'm going to take it apart through this video and put it back together, just to point out some things that I noticed. The lathe, when I bought it, had a 1 horsepower motor on it, which is okay. I mean, it's not going to hurt anything, but it's far too big for what this lathe needs. It came with a quarter from the factory. Many people upgrade to a 1/2 horse. This came with a 1 horse on it. Near as I can tell, it's an old furnace blower motor. But it'll suit me fine. I already mounted it up. I got the belt for it and so forth. I did not repaint the motor because it's not going to stay. It's hideous looking. I'm going to probably try to hunt some vintage Westinghouse or General Electric, something more period correct, to put on there. This motor is probably from the 50s or 60s. I did take it apart far enough to clean the centrifugal switch contacts, and got all the junk out of the felts for the oilers, and resaturated them, and oiled the plain bearings down good. Put a new cord on it. The old cord was pretty well spent. That's a word I picked up from the British people. There was this British car show where these two fellows would buy an old clunker in Great Britain and fix it up and sell it on, as they said. But they would use words like particular feature was spent, or an item was perished. So I don't know why those words entertain me, but sometimes I've mixed those words, which are not at all North American, into my vocabulary. But the old cord was spent. It was pretty well perished. So I put a new cord on it. Pretty much everything I've had to buy and not make, as far as brand new stuff, has been available from McMaster-Carr. I love McMaster-Carr. Naturally, they've been a vendor at every place I've ever worked for forever, but I never realized that the average person could just open an account with them and order stuff and have it sent to your house. The great thing about McMaster-Carr is you order stuff usually by about 2 in the afternoon, and more often than not, I have it the next day, which is awesome. If I want to use it the next day, it's there. Very often I can't get to it, but I was able to order, although I could have went down to the electrical supply house and got 16 gauge 5 conductor cord. It just it's easier, just a couple of key clicks, and have it show up in your doorstep. I got it in the color I wanted. I think I had insulation thickness options and everything. So the cord grip I had, but I think I'm going to take this horizontal countershaft apart now and talk about some of the things that I did to it, some of the things that I found wrong, and go from there. I think I'm going to take this horizontal countershaft apart now, talk about some of the things that I did to it, some of the things that I replaced. I'm going to take this grossly oversized motor off first. I'm going to keep the camera running, but I have a feeling I'm going to edit some of this out. The nuts that hold it on, there were bolts through it, but I'll explain why I have nuts now. The nuts that hold it on I ordered from McMaster-Carr, and since everything's black on the pre-1930s South Bend lathes, I ordered some blackened flanged nuts. These are 1/4 tappings in the horizontal countershaft casting, so I ordered some blackened flanged nuts from McMaster-Carr. They cost hardly any money, and I don't know, I like details. So ordinarily a 1/4 nut would take a 7/16 wrench. The flanged nuts are a little bit oversized, which is perfect. They take a 1/2 inch wrench. Have the motor off now. This is the original South Bend pulley, near as I can tell. Take the set screw out of the pulley to talk about it for a second. My high quality Tractor Supply clearance bin Allen wrench set. Oh, I hope if I'd use American. This is South Bend pulley. It's all turn steel, 5/8 shaft for the 5/8 shaft on the motor. It says AX25 on the back, which I believe is the South Bend part number. Curiously, which makes me think this is a mishmash of parts that I got here, it's a single groove pulley, but a double shiv on the countershaft. So I'm not sure how that's supposed to work out. But eventually, there's prints online. There's prints on Practical Machinist. Somebody's drawn up for the double groove pulley, so that you can just move the same belt from one to the other without having to have 2 sides belts. So eventually that's an upgrade I'm going to make. But for now, the single groove pulley cleaned up real nice. Thank you, Evapo Rust. Move the motor out of the way here. I said I was going to talk about why I'm using nuts and not bolts. I was concerned about the noise because the South Bend 9-inch lathes are famously clickety-clackety noisy anyway. So I wanted to isolate the motor a little bit. It's not a resilient mount motor. It looks like a resilient mount motor, but they're solid mounts in that mounting frame. So I got these at McMaster Cars. See if I can get one unscrewed. They're a couple dollars a piece. They're called sandwich mounts, and it's rubber molded between two separate 1/4-20 studs. And I thought this might help quiet the motor down a little bit and take a little vibration out of the shed here. I have a feeling when the lathes run, the whole shed's going to vibrate like you're beating on a drum. But I put these sandwich mounts in the 1/4-20 tapped holes, and the stud of course sticks out the other side. That's why I can use nuts. And I feel like that was an upgrade. We'll see how it pans out. The belt, as a result of spacing the motor out a little bit, the original belt, which I think was an A39, which is probably like a 41-inch belt, wasn't long enough. So I had to measure for a new belt and go down to the auto parts supply. I got a, what do I have here? A 4L420, which is a 42-inch belt, so it's an inch longer than the A39 that was in there. I forget which one is which. Like 4Ls are supposed to be lighter duty than A's, or maybe A's are lighter duty than 4Ls. I don't remember, but they're the same cross section and everything. 4L and A for this application, I don't think it's going to matter at all. By the time it's spinning up here, it's not really going that fast. So there's my belt. A little tricky to measure because to measure for a V belt, you measure around the outside dimension of the pulley, but you can't measure. So the pulley's mounted down here in the motor. You can't measure outside to outside up here because there's no pulley to be outside. This is what they call a V to flat. So you kind of have to imagine a belt on there when you measure. Pull your tape here a little bit, ½ inch high or so the whole way around, then back around. Measure with like a tailor's tape measure, something flexible. On the side here, I didn't paint it because it's a nice machine surface, but on the side are two holes. One's just a drill hole, smooth, and the other one's a tapped hole. It looks like it's 3/8 18 or so. Ted, the lathe man on the Practical Machines website, the expert on everything Selfman, said that was for an optional guard that was possible to have on this. Although I've seen plenty of 10K guards available for sale, I've never actually seen this optional guard, and I can't really picture how it mounts with a tapped hole and presumably a dowel pin hole. But I'm keeping my eyes peeled. You might notice the big double drive sheave or double drive pulley, whatever you'd like to call it, it's on with a taper pin. I purposely left my taper pin long. It's a number 4 taper pin, but I ordered a long one because they're so famously difficult to remove. And maybe I want to remove it someday. There aren't going to be any kids out here. This side will be against the wall. I'm not going to get tangled up in it. So I left it long just to make it easy to remove someday. I'm not going to take it out, take the taper pin out. I'm going to pull the whole shaft out, sort of in situ. But there's not much to see down here at the bottom. These two adjusting screws for the pivot have a straight slot. I had to remake one. The slot was all buggered up from Hammer Mechanic at some point. So I re-blackened the two pivot screws and blackened the one I made and re-blackened the original one, and I polished the nuts. I rather like the look of blackened hardware and polished nuts, so I blackened a great many things on the lathe, as we'll see at some point. But that's about all there is to say about the pivot assembly. Up here at the top, the triple drive pulley, the cone pulley as they call it, for the speed adjustment. There's a set screw, there's a clearance hole in the top, the set screw goes down and locks it on the shaft. There's a little dimple in the shaft. I'm going to take this off now, which is this size. You have to loosen this to be able to pull the shaft out. There we go. Alright, I got the set screw loosened, have it out of the pocket. It's important to have it back the whole way out because you can have it out of the pocket and still have it dragging on the shaft. The next thing is this set collar here, which I also ordered a new one from McMaster-Carr. The old one, someone had channel locks or something on it at some point. It had pipe wrench marks and so forth all over it. Yeah, we'll get the right size here. I should have brought my T-handles out here. Don't know my own strength sometimes, I think. But after that, that set collar is loosened and the center screw in the cone pulley is loosened, the whole shaft can pull straight out. There's going to be a few things fall out here, and we'll talk about them. First, the cone pulley. This is that set screw that I loosened down inside there, and it's got a jam nut on it. So once you get it driven down in, get the set screw down in, you can dog it down with that jam nut. The jam nut goes into a dimple in the shaft that approximates the angle. I actually made a new shaft, and I'll talk about that in a sec. But I think that the included angle of the point of a set screw is 90 degrees. I didn't really have anything at hand that'll make 90 degrees. I can make 60, I can make 82, I can make 118. So I think I said the heck with it and drilled the dimple with a 118 degree point drill bit, and then ran down in it with an 82 degree countersink, or maybe it's a deburring tool. And in any event, I have a dimple that will keep the cone pulley from rotating, keep it indexed at least anyway. So that's the cone pulley. Next to the to these castings, ordinarily from South Bend would just be this set collar. One of the things I did was got this thrust washer from McMaster-Carr, oil light thrust bearing, oil light thrust washer, phosphorus bronze thrust washer, I don't know. I just thought it would be a good idea to have that there and have it at least to be, instead of spinning steel to cast iron like it was before, at least have it spinning steel to oil light bearing to cast iron. I don't know if it was necessary, but it made me feel good to do it. I noticed on the old shaft, when I pulled it out, this is the old shaft, the original set collar left quite a mark on there, and it actually damaged the bearings. I didn't realize that it had raised up such a burr. It actually damaged the bearings when I was pulling it out. So on my new shaft, we'll rotate it around here, I milled a little, I don't know if that'll show up or not, but I milled a little flat in right there, just enough to get it below the surface, so that if it's going to raise a burr from binding that set screw down, it'll be in that flat and won't affect the bearings when you pull it out. Should have brought the old bearings out. There's actually 4 bearings in here. They're phosphorus. This shaft is 7/8, by the way. Phosphorus bronze bearings. They don't go the whole way across. It's 4 separate pieces, and there's about a 3/4 inch gap in between. I think I bought 2 1.25 inch bearings from McMaster-Carr and cut them in half, chamfered them, and pressed them in. I had to make a little doodad. This is just a piece of scrap that I turned down a little under 7/8 ID and a little less than 1 inch OD, so that I could put against these bearings and put them in the press. You could use a C-clamp too, and you can push them both through one way or the other, but it was handy for putting them back in also. So I used that to press the new bearings in. The old one's out and the new one's in. I don't know how I'd have done it otherwise. after these bearings were in, because it's a pretty tight press in there, they went a little undersized in the ID. They fit my new shaft perfectly, just sliding them on out of the box. But after I had them pressed in, they went just a hair undersized. And I also discovered that these two pieces of the casting are not in a direct line. This one's actually twisted. Not much, but noticeably when you slide a turn ground polished shaft through. So since it was so little, I got a chucking reamer, and I'd like to have had a 7/8 piloted reamer. A piloted reamer would have a long extension on it and a cone on the other end to line up through both bearings and run it through. Well, what I did instead, there was so little to take out, I could actually turn this by hand. I ran it through both on this side, and then I used this little plastic bushing, reducing bushing that comes with grinding wheels, and it's a 7/8 OD by whatever this happens to be, OD. And by the time it was up ready to go into this bearing, I slid this over to hold this sort of in alignment back here, and then hand turned it through the other two. And I was basically taking off dust, but it worked out okay. Poor man's line boring, line reaming, you might say. Some people put drip oilers on here, and I may at some point. I put drip oilers on my headstock, but I thought for now the Gitz oilers are okay. I should have brought out my tool that I insert Gitz oilers with. I have a little screw, little machine screw that I turn down to the ID of the pocket down in there, and then the OD of the cup, or the ID of the cup. It's like a stepped tool that I put in there and tap in with a little dead blow. Otherwise, you mash these Gitz oilers up trying to put them in any other way, because I have paint in there and it's usually a tight fit. But I don't know what you would call this feature. I want to call it the headstock of the countershaft. In any event, that's pretty much everything about the casting. Of course, it was stripped and painted. I've been feeling pretty good about the implement enamel that I got at Tractor Supply. I've been brushing some and just spraying a little, but it's a Valspar. No, wait a minute, Magic Paints implement enamel from Tractor Supply. So it is, and I feel like it's done a good job. This is the old shaft. You notice it's stepped at 7/8 where it goes through the bearings, and it's stepped down to 3/4 to go into the into this double pulley sheave, whatever you call it. Stepped down to 3/4. It was stuck in there so badly that I had to bore from the end. That's why a goodly portion of the end is missing. I had it in a 20-ton press and it wasn't budging. I have a feeling there was quite a rolled burr or something from reaming for the taper pin originally. So I had to drill in there, I think 5/8, and peel out the little piece. That's why this one's so much shorter. But I had already determined I was replacing it anyway because the bearing surfaces are all messed up, and I wasn't putting that in new bearings. So this is overall length. Original was slightly less than 12 inches, 11 and a half or something. I just ordered a 12-inch piece of turn ground polished rod. This might actually be chromed rod. I forget, from McMaster Car. It was $5 maybe. And since I had to turn that step on the end anyway, where this double pulley goes on, I decided to check for concentricity between the bore and the outside where the belt goes. And I don't know why my gut told me to check that, but this surface to this ID of the bore were not concentric by a goodly amount. You can see it with your eye. I didn't bother to measure it. I could see it with my eye. So since I was going to have to turn this step down anyway, I bored this out of this pulley to 20 millimeters, which 20 or 22, 20 millimeters I believe was the next step up from 3/4, because on the back side here it's trapped between the step and the pulley. I got a hardened washer and a needle thrust bearing and another hardened washer. I wanted to put that on this side so that as this rides up against there, it's not wearing out the cast iron. I actually have a needle thrust bearing in there, and I could get that in a 20 millimeter ID from McMaster car. And so that's what I did. I have a needle bearing with hardened washers on this side, and on the other side I have a I could have just as easily done another needle bearing, but I had the phosphorus bronze washer. It's a little bit of an experiment, just see which one gives better service. I'm all lubricated up now. So that's about the long and the short of the counter shaft. I'm actually not going to take this taper pin out, only because this is a little bit of a press. I think I actually turned this step on this shaft to 1 or 1.5 thousandths bigger than the ID in this pulley, and then drilled and number 4 taper pin reamer, drilled and reamed the everything in place and tapped the taper pin in. If I ever want to take it out, the taper pin is going to come out easy, but I'll still have to press this out, and it's pointless. So I'm going to put it all back together, but that's everything I know about the horizontal countershaft. Thanks, guys.